Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So today's challenge is a really interesting one and I will request you to stay till the end of the video because you will learn a lot of maths, okay, a lot of mathematical intuition in solving CP problem. And the coding portion is very easy actually. Okay, the coding portion is absolutely easy. All you need to understand is the proper bit manipulation, whatever is there in this problem, and also a lot of mathematical intuition. So we will see this problem. Let's try to understand the problem statement at first. Okay, so minimum operations to make the integer 0. You are given two integers num1 and num2. In one operation you can choose an integer I in the range of 0 to 60, and what you can do is subtract 2 to the power I plus num2 from num1 and return the integer denoting the minimum number of operations needed to make num1 equal to 0. Now if it is impossible to make num1 equals to 0, then return -1. So what you are told is that you are given only two numbers, okay, so num1 and num2. What you can do in each operation is that you need to reduce this num1 to 0, and in each operation you can take something like this: num2 plus 2 to the power I, and this I can be ranging from 0 to 60. So you can subtract, let's say 2 to the power 0, which is 1, or you can subtract a very large number, let's say 2 to the power 60. Okay, so I hope you understood what the problem statement says at least. And we need to find the minimum number of this many operations. So how many times we need to subtract this? Okay, that is nothing but the minimum number of operations. This is what we want to calculate, minimum number of operations. Okay, so if you try to find the range at first by looking at the problem, you see that yeah, there are some things and I want to reduce this num to 0. So what can I do? I need some minimum number of operations. So what can be the worst possible, biggest possible and the smallest possible this number of operations can be? Okay, so let's try to see this. You can see that you want to make this whole thing to be 0, right? So I can write it something like num1, and I am using let's say x operations. Okay, in total I used x operations. So this many number of times I will subtract num2. So it means that I subtracted num2 x into num2 number of times, and x times 2 to the power I wrote, where I was anything from 0 to 60, right? So what is this is nothing but minus x time powers of 2. This is what I subtracted, and I want to make it 0. Okay, I want to make it 0. Now you see what is my objective to find right now is that what can be the possible ranges, what can be possible ranges for x, possible ranges. What do I mean by ranges is that what is the largest possible x value? Okay, what is the largest possible x value that I need to do? Okay, that is the number of operations what I need to do. Okay, so you see I will just name few things. Okay, just is for easy understanding. Let's say I want, what my objective is that I want to reduce this num1 to 0, right? This num1 I want to change it to 0. Now in order to do so I need some things. Okay, now this I have this term and this term. Let's say I will call this term as my hero. Just I'm naming it for easy. Okay, we can name whatever. I'm just calling it, this is my hero, and this is my aid, something which will aid me. Okay, something which will aid me. So let's assume, let's say that this hero is mainly responsible for reducing this number 1 to 0. Okay, now aid is also aiding it, aid is also helping it to reduce it to 0. Now you see there can be two cases, right? You see, if you try to see, if you have read the problem statement very well and tried it on your own also, you see num2 can be negative also. It can be negative of 10 to the power 9, it can be negative of very large value also. So what you can do is that you can take two cases. Case 1, num2 is greater than 0. what will happen, you see, when num2 is greater than 0, num1 minus x times num2, this num2 when it is greater than 0, it is multiplying with a negative value, and it is helping to reduce num2 num1, okay, helping to reduce num1. So this role of this aid is helping the hero, okay. It is something like this. The role of this aid is helping the hero in reducing this num1 to 0, okay. Case 2, what is this case 2? Is nothing but, let's say this num2 is less than 0. What will happen in this case? You see, when you try to do num1 minus x times num2, it is instead of helping to reduce 0, it is increasing num1. It is instead of helping to reduce num1, it is increasing num1, okay. So it is sort of anti-aiding, okay. So instead of so what I can write is that this aid is now anti-helping type of thing, okay. It is not helping you, it is going against you, So then what is the job of the hero in this case? The hero's job is that reduce both, okay, let's say this num1 is, let's say I can write this num1 is negative, right? So I'm writing it in the form of, let's say, minus n, okay. This n is positive number. So what I can write, if I replace it, you can say that num1 becomes positive x into n, and this whole is a positive value. Now the job of the hero becomes more difficult. It, instead of reducing only num1 and instead of aiding it, you need to reduce this whole number, okay. So instead, let's say num1 was a 30-bit number, 31-bit number, since it is of 10 to the power 9, it is already told. So here the hero's work was to reduce 30 or less than 30-bit number, because num2 is also helping to reduce to some extent, so maybe less than 30 bits also, so less than equal to 30-bit number. The job of the hero was this. But you see, here it is not helping, it is anti-aiding sort of thing. So this, what can I say is that this is a 30-bit number, and this can also go till 30-bit, because num2 is also 1 in 9. So the hero's job is now to reduce a 60-bit number, okay, a 60-bit number to 0. Now you try to see that if there is a 60-bit number, and there can be, what is the number of possible ones it can have. So what is hero? Hero is nothing but 2 to the power I, right? 2 to the power I, and you know that let's say 100, this type of thing, this is nothing but 2 to the power 2, okay. This is nothing but 2 to the power 2, this binary number is nothing but 2 to the power 2. So 2 to the power I is nothing but a number which has only single one, okay. Now you need many 2 to the power I. How many exactly? You need x such 2 to the power I, x such heroes, okay. So but hero needs to decrease this 60-bit number to 0, okay. So you see, this 60-bit number can have, at the worst possible case, 60 ones, okay. All it can be ones, and hero has only one in his binary representation, so it can go till 60 times. So what do you get out of all these analysis? By doing all this analysis, what do you get? What do you get exactly? So what we had initially, let me write it again, is that this number 1 will get subtracted by number 2, as we are doing x number of operation, and we have an x bit number, okay. X bit number, x bit, not x bit number, x times powers of 2, x times powers of 2. You need to make this whole thing to be 0, okay. And what we saw is that what all these analysis taught us is that 60 times is the worst case. X can be worst 60. So the number of operations which you are asked in the question, your answer, this output, whatever this output you see here, the output is 3, here output is -1, means it cannot be done. Okay, so this output can go till 60, it cannot go above that. You see, this output cannot go above that. So one, if you notice this thing, if you notice that x can be worth 60, so the idea which immediately comes to your mind is that iterate through all possible values of x, all possible values of x. Don't forget, what is x? Is nothing but the number of operations. Down the number of operations, in order to reduce num1 to 0, you need how many? At least one operation. So x is nothing from 1 to 60, both including closed range. Okay, so x can be, you might need one operation, you might need two operations, you might need three operations, till 60 you might need 60 operations in the worst case. Okay, now there is still a lot of things in this problem. Don't get satisfied by, okay, I can now reduce this, I can just iterate through the number of operations. Definitely you can pause the video and you are free to try it on your own first also. That will definitely benefit you. But you see, there are still a lot of things. What is that? Okay, so you see, what you can write now is that you can do something like num1 minus x times num2. Okay, this you can write x times powers of 2. Okay, now the thing is that this whole number is some number n, right? Let's say this is the remaining number which we want to reduce. Now this remaining number may be greater than n, num1 may be less than num1, depending on whether num2 is positive or negative. That I don't remember, that I don't concern about right now, because all I need to find is that x can be a 60 bit, at most 60, and now this remaining I need to reduce to 0 with x times powers of 2, with x times powers of 2. Now let's say, let me on a totally different let's say I am taking a totally different problem. Let's say I have this number 13 and I gave you this number 13. Okay, I am giving you this number 13 and asking you, my question to you is that uh, you can subtract powers of 2 only. See, from remaining also you can only subtract powers of 2 x times. Okay, so I am asking you, I am giving you a number 13 and asking you, if you are allowed to subtract only powers of 2, so subtracting only powers of 2, okay, what is the worst and best number of steps you will need to reduce n to 0? Worst and best number of steps you will need to reduce 13 to 0. I will write a generalized case, n to 0. Okay, so if you see this problem at first, what can it strike to your mind? Let me represent 13 as its binary representation. What can it be? It is nothing but 1 1 0 1. This is the binary representation of 13, right? Am I right? Yes, I am. Okay, so what you can see is that from this you can write this as 2 to the power 0, 2 to the power 2, 2 to the power 3. This will be nothing but 13. So you can see, easily tell me that in first operation I will subtract 2 to the power 0, it will become 12. I will subtract in the second operation 2 to the power 2, it will become, what it will become? It will become 8. I will subtract 2 to the power 3, it will become 0. In this way I can reduce this 13 to 0. So first thing which will come to your mind is this. Okay, and this is the minimum, this is the best you can do. So how many steps you took? You took 3 steps. So best number of steps you got, this is the best number of steps. But what is the worst you can do? What is the worst you can do? You see, you can write this 13 as 2 to the power 0. My wish, I will write again 2 to the power 0, again 2 to the power 0 till 13. I am asking for the worst case, right? So how many steps you will need here? You will need 13 steps here. You will need 13 steps here. Okay. Now for this 13, for this 13 you saw that you need 3 steps or 13 steps. What about the remaining steps? So what if I ask you, so let's say 13 I have already explained you that you can write it in 3 steps. So but I am asking you, write it in 4 steps. Can you do it for me? Can you do it for me? Definitely you can. You can write 2 to the power I as nothing but 2 to the power I minus 1 plus 2 to the power I minus 1. I hope you can understand this. And definitely this 13 can now be written in, if I asking you for, this is for 3 steps, I am asking you tell me for 4 steps. You will do 2 to the power 0, you will write it as 2 to the power 2, you will write it as 2 to the power 1 plus 2 to the power 1, and it will give you 2 to the, it will also give you 13. Now what if I ask you, give me 5 steps to do it? You will do nothing but 2 to the power 0 plus 2 to, you will reduce this 2 to the power 1 to 2 to the power zeros. Okay. Now I am asking you, give me 6 steps. You can again reduce this, or you can even break down this one also, right? 2 to the power 0 you write 3 times, then it's 2 to the power 1, and this 2 to the power 3 can be written as 2 to the power 2 plus 2 to the power 2. Okay, I hope you can understand. 4 plus 4 8, and 2 to the power 3 is 8 also. So you see you have 6 steps right now. So you can keep going every step. You can keep going every step till 13 till you reach 2 to the power 0. So what do you observe from here? What exactly do you observe from here? Every possible step from 3 to 13 is reachable. Okay, every possible step from 3 to 13 is reachable. In general, if I ask you how many for a number n, what will you tell me? What is 3? Number of ones in the binary representation of 13. So you will say that it is nothing but bit count, bit set bit count. Okay, set bit bit set count of n to n. So for 13 it's 3 to 13. For n it's bit set count of n to n. Okay, so number of ones in the binary representation of n to all the way till n. Okay, so you can do this. Now what was the point of all of these things? I wanted to, now you see my former problem is something like this. I don't want to I don't have an n, but I have a remaining which I want to subtract x times powers of 2, exactly x times powers of 2. So instead of n, instead of this n, I have remaining now. I want to reduce it to 0. In the same way I have reduced it to n, subtracting x times powers of 2, x times powers of 2. Now what can be the range of x? Definitely it will be bit set count of remaining, 2 remaining. Okay, now you see if you do something like, you can just check the values of x and the problem is done. If you have x is greater, x should be between these two, right? If x is something greater than remaining, it means that remaining is so small, you cannot possibly decrease it. Even after one operation it will become a negative value, so it is not possible. You just return -1. And if x, so okay, so you write this statement, and if x is nothing but greater than or equal to bit set count of remaining. Now bit set count is, I am nothing but, I am reminding you again that bit set count is nothing but the number of ones in the binary representation of remaining. Okay, so if it is greater than that, what will you return? Return x. What is x? Number of operations. That is what was our answer, right? If x is greater than this, and that it is not this also, it is if it is less than or equal to remaining. If it is not greater than remaining, it is definitely means that it is less than or equal to remaining. And you can now see is that you have got your optimal operation. So the problem actually becomes very easy. The first thing which we concluded is that x can be up to 50, x can be up to 60, right? Can be up to 60. So this is the number of operations, can be up to 60. So you can use a simple for loop. Go from x equal to 1 to x equal to 60. Now what you will do, you will calculate remaining. It is very easy to calculate. Num1 minus x times num2. Okay. You just calculate this remaining, and you need to reduce this remaining to 0, remaining to 0. So there is a function known as built-in pop count. It gives you the number of ones in the binary representation of a number. Okay, so what you will do, built-in pop count of remaining. Okay, so if you can try to calculate this, you will see that so sorry for this, if you will try to calculate that particular x is greater than remaining. So if you see that x is remaining is less than x, or x is greater than remaining, what you can do, you can return -1, because there is no possible way in which you can further reduce the remaining to 0, because now it is now after the next operation it will go to a negative value. Okay, and what you can do is also that if x is something, if what did I tell you, uh, if x is greater than or equal to this whatever thing you calculated, if x is greater than or equal to this whole thing, let's say this will something to be k, okay, then you can just return x. Okay, and at the end of the for loop, you can just write return -1. If there's nothing you can do, you can always return -1. So yeah, that is what this problem is all about. Coding portion is very simple. I hope you understood this problem. There was a lot of mathematics, and a different, very interesting kind of problem also it is, right? A different kind of problem, not involving much of a coding, but a lot of intuition based and mathematics. So I hope you understood. If you did not, you can ask me in the comment section, or I will suggest you to go through the video once more in order to make it very clear, and this will also help you develop your intuition to the next level. Okay, so what you can do is now very simple. I have an integer x, so I have the number of operations x, which can go from 1 and x can be up to 60. So and I will just check for each operations what I am having. Okay, so I will have, let's say, remaining number with me, which is nothing but num1 minus x times num2. Okay, num1 minus x times num2. Now you see this x times num2 can be a long, so let me just typecast this whole thing. So yeah, I have typecasted this whole thing, and now this remaining, what did I tell you, what were my conditions? If you try to see, if remaining is less than x, if this remaining is so small that it is less than x, you return -1. You don't have any other choice. Now if this x, what will our so you see that our x lies in the range of bit set of remaining to remaining. So I have eradicated the possibility where it can exceed remaining. Now I just count it. Okay, so if this x is greater than or equal to, okay, so if it is greater than or equal to this bit set count of remaining, we can return x. You can return x. But what is this bit set count? You can use a for loop also, or you do it in any way you write like. Okay, but there is a function in C++. If you are doing in Java, you just write a quick function that will count the number of ones in the binary representation of remaining, that you can directly get in C++ using this remaining. And if in your own language you know some function is there which can do this job, just use it. And if x is greater than this, then you have got this many number of operations. You are iterating through the number of operations, and you have got a favorable operation where x lies in the range, x lies in the proper range, and x can do the job. That is, the number of operations can do the job right now, and at the end definitely you can return a -1. So that's all, I guess. That's all. It will not be at all difficult to code. You see, you only wrote 6 lines of code, nothing much. Okay, so yeah, you got it accepted. If you try to submit it, you should get a good runtime complexity also. So you see, you get 100% bits on runtime and a 52% on memory. Whatever be the case, this is the best possible thing which you can do. So yeah, that's all for this problem. Hope you liked my explanation and definitely learned something new from this video. Okay, so I will meet you in the next video. Till then, thanks a lot. Have a nice day.